Guys, welcome back. So let's complete section 6-5. I made a video on Rhombi and I'm going to finish this section by explaining squares. So a square is a parallelogram with four congruent sides and four right angles. You will also recall that a parallelogram with four congruent sides is called a rhombus, and a parallelogram with four right angles is called a rectangle. So a square is both a rhombus and a rectangle. The Venn diagram, like this, will explain the relationship between parallelogram, rectangles, rhombuses, or rhombi and squares. So if this whole thing is parallelogram, that means opposite sides are congruent. And let's say so many of these parallelograms are rectangles. And so many of these parallelograms are rhombi. Then the intersection is a square. So rectangles, squares, and rhombi are all part of the parallelograms. So here are some conditions to prove that a quadrilateral is a rhombus or a square. So the first theorem is if the diagonal of a parallelogram are perpendicular to each other, then parallelogram is a rhombus. Second theorem, if the diagonals of a parallelogram bisect the opposite pairs of angles, then the parallelogram is a rhombus. So these two properties, we had done it before, but the third one is actually new. If the consecutive sides of a parallelogram are congruent, then it's a rhombus. If the consecutive sides, if two consecutive sides of a parallelogram are congruent, then parallelogram is a rhombus. Because in a parallelogram, the opposite sides are congruent. So if two consecutive sides are congruent, that means all four sides are congruent. Therefore, it makes it a rhombus. So there is another theorem that states that if a parallelogram rectangle and a rhombus, then it's a square. Alright, these are all the theorems, and now I'm going to do one question, actually one proof on rhombi or squares. Here is a paragraph proof on proving if a parallelogram is a rhombus or not. So we're given that JKLM is a parallelogram, and it's also given that this triangle JKL is isosceles, and I need to prove that it's also a rhombus. So I'm going to write a paragraph proof, but if you don't like paragraph proofs, then you can also write a 2-column proof. So I'm going to start with the given statement. Always start with the given statements. Since triangle JKL is an isosceles triangle, this is an isosceles triangle. So if it's an isosceles triangle, we can say that, therefore, segment JK is congruent to segment KL. Now, since it's also given that it's a parallelogram, and if in a parallelogram 2 consecutive sides are congruent, then it's a rhombus. It's also given that JKLM is a parallelogram, and we just learned that, and we know that if 2 consecutive sides of a parallelogram are congruent, then parallelogram is a rhombus. That's a theorem we just learned. And that's it. So hence proved. Thanks for watching.